Hello, and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a few minutes. In this example, I'm going to demonstrate a new T-Rex wall boundary condition that's available in the volume solver. To demonstrate this, I have the PAW 5 geometry. That's the Propulsion Aerodynamic Workshop. And as you can see, this geometry consists of a nozzle and it blows over this aft deck. And this aft deck has cooling holes in the surface. Now, I've already created a mesh on this geometry. And let's go in and select a block. We'll go into the solver. And let's examine this existing block. And I'll show you the regions we're going to change. I'm looking at volume ratio. And I'm going to turn on a cut. And I'm going to set a value so that it cuts through the cooling holes. And let's turn off the database and let's go in and look at what's happening in those cooling holes. And you can see the T-Rex layers that have advanced off the surface and eventually collide with themselves. And this is the resulting TETs in the transition region. And you can see that we have some large volume ratios in those regions. And this is what we want to improve. So one way to improve this would be to reduce the number of T-Rex layers to start the transition earlier. Now, in previous versions, to do that would change the number of T-Rex layers everywhere in the mesh. But with the new feature, we have more control over how we set the number of T-Rex layers. So let's exit out of the examine. We come over to the Boundary Conditions tab, and I'll scroll to the right. You'll notice that we have a new column available here called Max Layers. And this is where you can actually specify the number of T-Rex layers that you want. It will default to the global setting, but you can individually change that. So what I'm going to do is I'm going to select all the holes. If we look at our boundary conditions now, I have a wall boundary condition over this entire geometry. But what I want to do is create a new one. So I'm going to select just the holes. And if I use Control Shift as I drag, that's an inclusive, it'll just grab everything inside the box. And I'm going to do that for all the sets of holes that we have. And I'm going to create a new boundary condition. And I will add all these holes to that boundary condition. Let me go ahead and rename it holes. And it is going to be a wall boundary condition just like before. And I will set the same spacing off of that wall that I had previously. But now when I come over to this max layers, I can actually set a value here. And I'm going to set that to 20. Now we can come back to the Solve tab and let's go ahead and initialize this mesh and we'll see the difference. Okay, now that our block has been reinitialized, let's go in and examine the volume ratio again. We'll zoom in along the holes. And now you can see that the T-Rex layers, in fact, did stop earlier as we specified. And this allows for a much nicer transition to the TETs on the interior, as you can see by the triangles. And our volume ratios are much better in this region. This is one example of how you would use this new T-Rex boundary condition to improve the quality of your mesh. If you like this video, please click the thumbs up button or subscribe to our channel for more videos like this. If you have any questions, comments, or suggestions, drop us a line down below or connect with us via LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.